For decades, we've seen an intense selection in livestock for performance-related traits, like live weight gain or milk or egg production. This may have resulted in resources being allocated to production at the expense of other physiological processes such as immune function. Within the SusTradeOFF project, 10 research partners from across the globe have joined forces to study these trade-offs. They want to know things like, does the animal allocate more or less protein to production or immune function? How is this protein allocation affected by genetic background, stage of production, disease, or vaccination? And does the protein source have an effect? To answer these questions, the SusTradeOFF project used 2 animal models, one in chicken and one in sheep. Let's look in more detail at what we did in sheep. At the INRA experimental farm in France, divergent lines of sheep were selected for resistance to a gastrointestinal parasite under controlled infection conditions. The sheep's level of resistance was evaluated by the number of parasite eggs in their feces after experimental infection. After 3 generations of selection, the resistant line has 10 times fewer parasite eggs than the susceptible line. First, we wanted to check if the selection for the lamb's parasite resistance was also efficient in adult ewes. To do so, we infected our sheep lines with a gastrointestinal parasite at 4 times. During growth, first lambing, early pregnancy, and second lambing. Each time we counted the number of parasite eggs being excreted. We found that selecting for resistance was effective, not only in the growing lamb, but also during most of the reproduction phase of the adult ewe. Both lines were susceptible at one time, at the end of pregnancy and around lambing. This suggests that both lines undergo a periparturient drop in immunity at this stage of high nutritional demand. In the SusTradeOFF project, we also used these divergent lines to identify if putative trade-offs between parasite resistance and production traits exist. And we tried to model these trade-offs. The growing capacity was estimated several times for 90 lambs and 50 pregnant ewes. We measured the animals' food intake using an automatic register, weighed them using a dedicated scale, and measured their back fat and muscle using ultrasound. We also measured the number of lambs, lamb mortality, and milk composition. We found less back fat in the resistant lambs than in their susceptible counterparts, meaning that the development of an effective immune response can require some energy. To quantify this energetic cost and predict what the trade-off between production and parasite resistance would be, we used mathematical modeling. The model represents the allocation of energy intake between production and immunity. On these plots, you can see that the points are experimental observations and lines are model predictions. This means that the model accurately predicts that susceptible sheep have a high fecal egg count and they give priority to fat growth, whereas resistant sheep allocate some energy to immunity and thus deposit less fat. So it's possible to simulate at population scale how selection can affect the trade-off between resistance and production. The next step is to apply this trade-off model to the peripartum period and to determine the biological mechanisms involved by measuring the protein turnover. In chicken, we also identified a trade-off between production and antibody response and a relation between resilience and immunity, with more resilient chickens showing less fluctuation in production than less resilient chickens. It will be a challenge to fully understand the underlying biological mechanism of these trade-offs, but we can already turn our project results into practical advice for farmers. For instance, besides the option of selecting for parasite resistance, we recommend that peripartum ewes are either kept inside or that antihelminthics are given before lambing, even for the resistant ewes. We have provided prediction models for trade-offs in sheep and have proposed decision-making tools like resilience indicators in chicken. In the future, we expect to generalize these models. Decision tools for farmers and breeders will lead to recommendations at the farm system level. Together, these measures will contribute to improve livestock health and welfare and will help to reduce the environmental impact of livestock production.